In this video, we're going to be discussing motion constraints inside of Autodesk Inventor. Now, motion constraints essentially have the ability to emulate movement of rotation or translation based on rotation like a rack and pinion, but don't actually show contact. As an example, if I had two gears in rotational constraint together, I can have one rotate based on a rotation of another based on a ratio, but they don't actually have to have contact. They don't actually have to engage their teeth correctly. It essentially is a way to show the movement without actually being too finite about how they're going together. Now, motion constraints don't get a lot of utilization in general because normally when you build an assembly with Inventor, you try to make it static. You try to make it so it doesn't move around a lot. However, if you need to show motion in order to better visualize your design, to create an animation, a video, a drive constraint video, you might want to consider these particular tools. So with our motion constraints IAM from our working files directory, I'm going to begin by placing a motion constraint that controls rotation based on the cyan component moving and the orange component therefore rotating based on that. I'll start my constrain command, and we are going to be focusing on the motion tab. Now, it's also worth noting that the motion tab does not have the ability to do limits of any kind. So I'll simply truncate the dialog box there. Now, as we look at the motion constraint, there's two types. We have rotation and relative to each other, as well as rotation translation. Now, depending on which one we choose, they obviously do different things. The first one, rotation, deals primarily with gear type elements. The second one deals more with a rack and pinion type of engagement for your design. We'll begin by looking at the rotation type, and we need to begin by selecting our two different rotational references. So here I'm going to rotate my design, and my first rotational reference will be this one here. I pick that circular reference. Now, the way this is set up is that my second reference will rotate based on a ratio of the rotation of the first. So for every rotation of the first, how many rotations does the second one get? Now, my second component will be the orange drive shaft in here. However, the selection that I want to have, it's become really difficult to grab based on my current visibility of the component. So I'm going to use the Pick Part First option from the dialog, pick my drive shaft component here, and now that that's selected, it only filters to grab elements which are part of this orange body. So I want to pick this interior surface here, and my ratio I'm going to set to 4. For the rotation, we can have the rotation be a forward rotation based on our selections, or a reversing rotation. I'm going to choose Apply here and close this. Now, currently this component is locked in place. I can't drag and move it. There's actually an angle constraint holding that in place. So if I expand my scallop here, you can see there's my rotation. If I look at my drive shaft and expand that, I have my rotation there as well. If I look at this angle constraint, let's try and drive that to show the rotation taking place. I'll right-click on angle 3 and choose drive. Currently, my offset driving value is set at 0. I'm going to make that go up to 1080, so you can definitely watch a lot of movement here. I'll go ahead and play that. You can see that as the orange drive shaft rotates, so does the outside scallop. Just rotate this a little more, see what's going on. As you can tell, I have some tangent constraints in there that are also allowing movement in other parts of my design. Let me reverse that. All right, very good. I'll choose OK. Next up, we want to look at a rack and pinion type engagement where we have a rotation of my drive shaft that will move this rack back and forth. Again, notice there are no teeth here. There's just simply a representation of what that rack would be. I can put as many teeth on there as I want. It really wouldn't matter. I'll start my constrain command again, choose motion, and then my rotation translation type. The first selection you make needs to be the rotational body. Here I'll choose the drive shaft. And the second selection needs to be a directional reference on the component you would like to move. So here I'm going to choose this edge vector on the rack. Now the distance here applies to, for every rotation of the first element, how much translational distance will take place. Well, this is actually about 10 inches long. I'm going to make my distance here 9 inches and choose apply. I'm going to go back to my angle 3. I'm going to drive this from 0 to 360. And if I move that back and forth, now why did that stop there and not go further? Well, I actually have a limiting constraint on there that keeps it from going off of the pinion. So let me cancel that. Let's take a look at the rack there. There is my mate 16, which is a plus or minus. If I look at that constraint, I have a maximum of 9 inches and a minimum of 0 millimeters. Change this one back to 0 on the rotation. So I successfully have different amounts of rotation as well as translation set up in this design. Now you can also link multiple rotations or translations together as well, which makes the ability to drive a constraint and control multiple motions much more favorable. If I look at my other example here, clock IAM from our working files directory, we have multiple rotations set up in here. Here, if I were to drive my constraint that's holding the gears in place, you can see it actually spins multiple elements for my rotations. Choose OK to close out of that. So this clock example, feel free to pick that apart at your will. I'm not going to go through and show how this was set up. It's just simply multiple rotations based on when one rotates, so does the other. And it's a fair amount of trial and error when you start putting a lot of these things together. Just watch which way you're turning things in forward or reverse order.